Hello everyone, welcome to another stream. How are we all doing? How are we all doing? So, last stream we were doing transforms for the UI. So we've got a simple test and the box, our bounding box is a little bit too big. It's meant to be bigger the other way. It's meant to be, I forgot actually. Yeah, it's meant to have shrunk instead of grown, something like that. That's it. So yeah, we're basically halfway through the work. And I'll kick off by describing like where we're at and what sort of things we're working on. But yeah, so we've got essentially like an API which allows us to transform our UI renders and pass up like a little matrix per draw. Hey there, Soul Foam Haze, how's it going? How you been? You been souling or foaming? Which one? Wait, it's in the why did I go into graphics? It was rendering code, so mine was like, that's graphics, but it's UI rendering code, right? So we've added the ability to now scale shapes, like individual shapes that you put down. So scale, rotate, translate, or skew. And scale, rotate, or translate, skew, the whole command, which comprises of many shapes, right? So we can do that when we do our draw code, and it's going to be pretty sweet. A little bit of both, to be honest. Oh no. I'll just crack that window open some more. I've been heroing. Yeah, I've been heroing. Yeah. I came back to the code base at work, and my boss, like, on Monday, not this Monday, but the Monday before, when I came back from paternity leave, was like unloading like 8 different things on me verbally, and then I wrote them all down, made them into tickets, and I just finished them today. So I've been hearing, that's for sure. Tons of little quality of life stuff at the work code base. Saving some cities and townspeople. Not quite. Maybe. I guess so. I guess so. But yeah, how's life going? How's the projects going? So basically, we've got the ability GFX-C to, where is it? So we got clipping in the UI, we did that the stream before, but we started doing translating. Yeah, this is it. So we can say like, oh, I want to put a shape down, but before we put the shape down, we say, oh, we want it to be scaled. So we're scaling it in the other way, and the bounding box is wrong. So I guess let's just start off by just explaining where we're at. So the way the code base works, right, is if you put down 3 circles, 3 shapes, and then say finish that draw. Well, first you say, you define a color for those shapes, and then you say you draw finish. It then will wrap. It kind of has built a bounding box, and the reason why you build a bounding box is because you can say, hey, color it with a texture, right? And so when you have the bounding box, it can map these into UV space, right, and then do a texture over it. So that's cool, but the problem is when we do transforms, the issue becomes a little bit more complicated, because we have to then, when we say we've got a circle and you want to say how it contributes to the bounding box, the circle could be stretched, it could be skewed, it could be rotated. Doesn't matter for a circle, but for a box it would matter. So we reapply the transform on the corners of the bounding box of itself, and then see if it goes outside of this one, and if it does, that's the new bounding box, right? Say if this was the bounding box, it would then get redrawn to be outside here or something, right? So the current issue is that in the shader, we need to provide an inverse matrix because we're taking a because the way I forgot the way yeah, we need to pass in an inverse matrix, but outside the shader we need to use the regular version of that matrix. So what we need to do is we need to edit this code, edit this UI code. So we're going to open up the internals and we're going to maintain two matrices. So there'll be an inverse matrix and a regular matrix. Dun dun dun. So let's go ham on that. So see, we're inverting it here. It's not a gooder. And we're negating the skew here. Don't do that. Then we're negating the scale. Then we're negating the skew. So what we need to do now is where we create the matrices. So we create that matrix. Here. Right. So yeah, maybe we put this into a function. Yeah, maybe we should have a little function that just says, given my scale, skew, translation, and rotation, give me a matrix. And you can also say, given those things, oh yeah, then we can invert them, and then it will give you the inverted matrix as well, right? So I think that would be a good idea. So and another thing as well is that we don't really have like a matrix type. I do have matrix types in my sort of HMaths library, but I don't think I have a 2x3, and we kind of need a 2x3. So we'll just have a little custom one that we'll do in this shared header, which is shared between CPU and GPU, you know? So I think what we'll do is we shall have we can delete this here actually. That's the old one. Then we'll call this UI matrix. Ta-da. Or we could call it transform. Matrix is just fine. So you would just basically say, here's your values. 6 values, ta-da. So wrapped in a strut, so it gets passed by value, that sort of jazz. And it's distinct. And then I think we can, in the internals, we want a way to be able to, where do I put it? I might put it in the internals for now because we can always move it out. This is the core part of the UI, I guess. UI matrix, initialize. So you have a float to scale, so we have non-uniform scale, which would be pretty cool. We'll also have a rotation angle. A rotation angle will also have a skew. Screw skew. So you can skew across the X or Y. Then we finally want to have the translation. What order did I do it in the past? Scale, skew, translation, rotation, okay. Right. So we'll have this new super lovely initialize function of the matrix inside the source code. And we're going to grab, in the past we've done this, right? So we just search for matrix equals. All you'll find is an implementation like this. Crap. So that pushes the matrix onto the end of a yeah, I guess we can just take in a pointer to it then. It's probably the best idea. So we'll just say, hey, can I have pass in the matrix like so? No, you can, it was modify it, right? Cool. Right, so then we'll look for matrix equals again. We'll just grab this. Just get to reuse that. So we have to swap these S and these these takeaways and that around the other way. And the reason why is because that inverts it. And we had it inverted by default. But then what happened is we need to actually have a non-inverse one as well. So the CPU takes the non-invert matrix, whereas the shader needs an inverted matrix. So then what we can do is just replace all of this with .v. Well, needs to be that. Then this can just be right, scale x scale y skew x skew y. Very nice. Cool. What's this translation about? Oh, just off. Oh, I had that right. XY. Fantastic. So, oh, this one as well. Sine cosine, please. Thank you very much. So there we've got that little reusable function there, I guess. So we need to be able to compute. See, the issue is we're doing sine and cosine twice. We're going to call this function twice. One for the inverse and one for the and that's going to happen all the time. Yeah. So I think we want to have so maybe we do this. It's internal, so we can do it can be as weird as it needs to be. And then because of that, we can invert these guys. So for this, you could just say this one equals 1 divided by sx. 1 divided by sy. This one is skx negative. This one is negative sky. And then this one is, well, we we could just inverse the maths instead of inverting the values, right? Hey there, Bassandro. How you doing? Welcome, welcome. How's things going? Yeah, I would rather just inverse the values rather than inverting this and hoping I got it right. It'll take more time, you know? And then we can basically just repeat this. Just do matrix. Something like that. Bam. Alright, so there's our reusable function at least. So now what we can do is go around and use it everywhere. So we want to look for matrix equals. So we need the matrix to be able to do a so maybe we can get rid of this function now. Oh no, but it resets the state, you see. So I think we'll take in the words that we want to modify, and then we'll take in the two matrices that we want back out. So we'll say like UI matrix out. I'm okay. Spent after work. They forced us to go to the office a couple of times a week. Yeah, I think it entirely depends on the work, right? Yeah, if you're literally just programming, working from home, if you're a trusty individual, is you know, I would say it's in a lot of ways more productive because you can just get on and do work and less travel time, tons of benefits. But yeah, going in the office is great for the team building, that's for sure. Like you can't do the team building as well work from home. Yeah. So do you actually manage to get any work done at the office if you go in there a couple of times a week? Or is it mostly just meetings, like in-person stuff? Yeah, I'm not doing bad. I've been back at work now a week and a couple of days. Well, not a week and a couple of days now, nearly 2 weeks now, actually. It's Thursday, isn't it? I thought it was Tuesday for a second. But yeah, I've just been back at work, just doing a bunch of like bug fixing and quality of life on the code base. Kind of put task on hold but until I finished it, but I just finished it all today, so the task that I put on hold is going to be coming back. So yeah, that's been cool. The baby's great. Baby's doing good. What else? Yeah, that's about it really. The project's going pretty cool. We've nearly finished with UI rendering, that's for sure. This is like one of the last features. Obviously I want to chuck a few more shapes on there, but besides that, this is basically one of the last features. And then we can get down to actually making the UI code itself rather than the UI renderer. Right, we spent a lot of time doing a nice Wait a minute. After this, we need to optimize the shader. So we get to do a fun little exercise of optimizing. We're going to do a tile-based renderer for it. So it just makes another pass, basically splits into tiles and optimizes that. And we'll maybe try and optimize the shader a little bit more and see if we can get it to be even faster. So yeah, because we already did that a bit. So just do it some more. Optimize. So we get two matrices. So the thing is we've got to have one matrix that just sits on the stack. So UI, this is the matrix, the inverted. Ooh, this is the one that we use. Wait, no, they're right here, matrix out. And yes, Excuse me there, my mind went a bit weird. So, I think it's the scale. I forgot. Scale skew. So here's the thing as well, is why don't we put that in a structure, right? Make it way better. So we'll just do internal for now. And the reason why I'm going to do the structure is because in the future, when we're doing, what we're going to be having is a way to make these, take the shapes basically and make a command and make our own little custom drawings out of circles and boxes. You can rotate them, you know, and do whatever you want basically. And it'll be a whole UI within the game to make our own little icons and stuff. And maybe also we can then bake that down into a texture if there's optimization that needs to happen. But the editor will need a structure like this basically, because this will be the state it will be using. It's, you know, scale, skew, translation, and angle, and probably have that per shape or whatever. Because a matrix is very, it's a combined thing, isn't it? It's a, you've lost information when you've turned it into a matrix, whereas this is these attributes individually, right? So we'll call this the UI transform. I'm glad I didn't use that word for matrix. So then this can just be all of this lovely. And then we take in via pointer, or a putter, as they call it. Something like that, right? And that will be even better. Oh, and then it's maybe catch all of this. Shoot. Linear algebra sucks, just my opinion. Yeah, you know, maths is always a bit, you know, makes your brain fry. But you know, it's a tool, and it's the best tool we've got for the job. So, you know, and also compared to other maths, it's not too difficult. There's tons of resources online that boils it down for people like us who don't really like maths. And you use it just for, you know, the bits you need just to do games, right? You know, so pretty good. Yes, there is hope. Maybe one day it'll click. Yeah, man, don't you worry. Like, so I've been able to use matrices and vectors for a while, and you know, I forget how to do certain things, and I'll relearn it again. You know, but like the format of a matrix, I've only recently got somewhat good at it, but it's still confusing. Like I've understood the format for a while, but actually been able to write one myself and like do it. It's still confusing, but I'm getting better. Yeah. You just gotta keep practicing, you know? That's all it is. Right, so this transform thing, we can just have that in our thing here. So we have one transform on a shape, and then a transform for the whole command. Dun 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 dun. Wow, so much better. And that's in our global state, which then means we can just feed it in here. So here we obviously just need the shape. GUI.shape transform, take the address, bam. Which then means that initializes two matrices, right? The standard matrix and the inverse matrix. which means we get rid of all of that. And we need a function to now also reset our transform. So we need a transform identity function. Oh, we've got a T here. Well, we're born with the math gift. The math gift. I don't know. Like my brain's always been like logic based, but like I don't really have a I don't really trust myself to do like you know like multiplying numbers and doing maths in my head. I just rely on a calculator. I did find some maths at school hard, but it wasn't too hard. But yeah, what I would say to that ACC is what I'm smelling is an excuse. Like, it's easy to be like, oh, this thing's hard. And it's easy just to make up excuses, basically. But just, you fail, try again. Fail, try again, and you just get better. That's just how things work. You know what I mean? Right, so we can just reset all this back. Things about these maths things is you basically write them and forget about them. For me, I conceptually understand them, but many times I can't write them without looking them up again. Yeah, that is true. Yeah, you will probably forget. I guess if you start writing it enough, you will remember. But then I guess if you don't do it for like 30 years or whatever it will be, there's eventually a time where you will forget again. That's true. But yeah, remembering how to actually use them is the main thing, what they can be used for. There's lots of little interesting things where it's like if you tear them apart and use them in you see like the proof behind what makes them like up from the ground up. Like I've seen some things explained and then I've forgotten about it again. But it's interesting to see it because it really combines the different concepts together, basically. Well, I haven't. I'm almost at high school level though. I agree with you. I can do Baskara, but I'm working on my own C++. Baskara. I'm not sure what that is actually. OpenGL game. Nice. That's really cool. But yeah, I wouldn't get so hung up about like not being good at it. Like my maths isn't like the best, but I just learn it as I need it, and then I just forget about it again. Yeah. The proof is fascinating. Is the fascinating part though. Seeing it work. Yeah, that's a point as well. It's like that's another thing as well. It's like half the time maths is hard is because you're not visualizing it. And it's not your fault that you're not visualizing it. The problem is the teaching material often isn't that good. So if you want to get a often you want to get a feeling for the maths before you really learn the theory behind it. And then you go and learn the theory behind it, it just makes it more sense that way. Like a prime example is like, well, a simple example is maybe like a dot product on a vector, where getting a feeling for it, seeing it in action. Like if you Google for this, or maybe someone's got some links, there's tons of interactive stuff online for that. There's also like cross products one you can see. Cross product is like dead simple when you understand it. Well, how it can be used at least. And what's the other one? But then the hard one is like a quaternion, right? Now that one I don't really I know how to use it, but I don't really understand the stuff behind it. But there are visualizations online. And I know some things, right? All the things have to add up to 1, components have to add up to 1, but yeah, that sort of thing. Hey Valseki. I've written code to draw a quad 1,000,000 times, but I still need a notebook to work out the indices and crap. I don't know, the indices are not so bad, are they? It's just like 1, 2, 3. Wait, so 1, 2, 2, 2, 3, 0. Yeah, you just sort of repeat them and get back around again. Yeah, not too bad. Yeah, it's just like your triangle is 0, 1, 2, and your other one is 2, 3, 0, something like that. And then that's like something like this. Voila. So it's triangle 1, triangle 2. But yeah, something like that. Yeah, they're not so bad. Yeah, visualizing. It's all about the visualizing, exactly. Yeah, if you don't do it, like that's the biggest problem. Like that's what fries your brain, right? When you're like puzzled by it, just trying to like decode the stuff in front of you. But if you just see it, it's just way easier to then look at the maths and be like, oh god, I see it now. Nibmine, welcome. 3 blue, 1 brown. YouTube does awesome work in that regard. Yeah, I remember seeing some of the videos. Actually, I should really watch more of them. Quaternions can be nuts to wrap your mind around until you start thinking of it as an orientation instead of rotation. Right. Gotcha. Yeah. Yeah, and I think as well, like I started getting into like I started researching into geometric algebra because so many people recommended it to me, and it's so. Wait, did I say identity on this one? And what's funny apparently is like there's a concept called a rotor which basically explains a quaternion in geometric algebra terms. And you know, it seems fun and interesting just reading about geometric algebra. Like it is really interesting. And apparently it just basically the code is identical, but it just explains quaternions using geometric algebra instead of that 4-dimensional sphere, whatever it actually the quaternion is. So if you're really interested in like learning more about like maths after linear algebra, definitely check out geometric algebra. I think people are starting to use it now in games, but I'm not sure how useful. Like there might be some really good applications for it we're not using yet, right? Basically. But I don't know. You basically get like a 2-dimensional. Well, yeah. I forgot the way you say it. Yeah, it's called a bivector and a trivector, where it's 2 vectors that are joined together and do. Yeah, it's interesting. I need to like watch some more videos on it. I think I can get a reference if people are interested. There's, sweet, I'm not signed in. Okay, so I think someone was doing it from like absolute scratch. Yeah, this guy. So he's done a Swift introduction into it, I guess, and he's also done like tutorials from absolute zero all the way to geometric algebra, which includes like learning about standard. Yeah. Anyway, drop a link in if people are interested. Okay, so there's my identity. So I want to do that frame initialize, where I've got a couple of guys here that want an identity matrix. Transform, rather. Sean McGrath did a great video on quaternions wanting lots of swearing. Yeah, Sean McGrath's a really cool guy. I like, it's really funny. I wish he made more content. You know? Is a lot of fun. Like, he's the type of guy where he could be angry and is funny. You know, whereas some people are angry. Well, like me, if I get angry, I look like a dick. You know, so I try not to get angry at stuff. Yeah, it's cool, dude. Those were the days. Yeah, I don't know how people do it. They get angry and they're funny. I have no idea. Yes, I'm still watching YouTube. Well, I wasn't watching, it was on in the background, but still. They have to be so pedantic. So when we make up, okay, so we've gone and done that refactor now, which is awesome. So we've now got this guy. So this is going to make us, so this is our clip shaped circle. So when we build up our clip shape, or our clip volume, I guess, if you want to call it that, it's weird. You can put a bunch of shapes down and then say finish, that's my clip shape. So we need a place to store shoot. We need the actual matrix to come out, but the inverse matrix actually. So the shader needs the inverse matrix, and we need the, okay. So this function actually needs to be, we just want the matrix to come out, which means it could have really just gone here. Okay, so we need, also we'll do another little handy function as well. We've got a way to like push. You know, I'm not fussed about it, to be honest. Yeah, I'm not fussed about it. Right, so push words many, and we'll get a matrix here. This has got to be the inverse matrix. So push on 6 words, basically, and that will go in here. And then we'll get a matrix here on the stack, I guess. Hopefully it gets inlined. Oh well. Not overly fussed. And then we can do identity transform on the shape transform, and voila. So we do this per anytime we use a shape, and the reason why, UI matrix. Hey there, not so red, how you doing? How you been? How things going me? Things going good. Wish I had that ability. Which one is that? Sorry, Travis, I was looking away for a second. How's oh, I know what you mean, the angry thing. I know. Right, I understand now. Yeah, good to hear, not so good to hear, my friend. Yeah, things going good. Things going good. Just been working, keeping busy, looking after the baby. I think the baby had be funny when angry. Yes. So yeah. Um. Yeah. The baby's been good. He's had a bit of stomach problems, but we got him some stuff for his stomach. Gave him a bit last night, a bit today, and it's been better. But yeah, a bit of trouble sleeping, but he's good now. Hey there, Psycode. How you doing? How's it going? But yeah, how's the compiler going? What are you working on next? Not so red in the compiler, because you got all the type checking done now, right? Are you fleshing out more features in the AST, that sort of thing? Right. So the beauty is right. So push on this little type to say, oh yeah, we're doing a circle, and then we push on a matrix, but the matrix should have the transform in there, which means it has the center position. Bum, 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 bum. So an optimization is you just delete that, and there's two less words going up. So we want to say GUI.shapeTransform.translation equals center position, and then you just delete that one. So now there's less words. So we've got to make sure we do that on the shader side as well. But no biggie. Right, so here's where it was messing up. So the matrix that we get back here. Oh, we've got to change this as well. Yeah, so we was supplying it the inverse matrix because, yeah, so the shader gets the inverse matrix now, and this code gets the standard matrix. So UI matrix pointed to a matrix. I'm working on runtime type informations. Multiple information. Very good. Very cool. Yeah, it's really handy having that stuff. Like, it's definitely like from a C based like the problem with C++ is that they try to give you all the tools to turn everything into a compile time problem, right? Um, and really, what you want is like you want the ability to do that for like basic things, but when it comes to advanced things, sometimes it's good just to have it as a dynamic problem, you know. And that's what runtime type information allows you to do. Is just move those just do those complex problems at runtime instead, and it will just be, you know, it gets to reuse the same function. So it could actually be better if so in some cases. But yeah, I do like that runtime type info stuff. Like for serialization, I end up basically doing that manually with macros anyway. Sometimes. So this one would then be, yeah, by the command matrix. Take the address. What the hell is going on? Oh. Much better. Rightio, sort that one out. Right, so I believe that's it. So there's our circle, right? So we push on the word say into the word buffer. That would be, the clip shape would be a circle. Push on the matrix, then push on the radius. Oh yeah, then push on the radius. Then here we're computing the bounding box, bottom left, top right. Then we're going to transform the bottom left, top right twice using the command matrix followed by the shape matrix, and then we're going to clip it, or we're going to update the bounding box for the clip shape. Perfect. So we basically want to take this stuff. Well, do that there like that. take these two things, put it there like that. So that's for the axis line bounding box. We will do more shapes in a bit. That should be fine. So we'll take all of this here, and now we'll go down to the other circle, right? So when we draw the circle, so shape circle, this one, we should be able to replace all of that. Voila. We're just going to make sure none of this says clip. Instead it says draw, because this is the draw shape for the drawing API. Then we copy this, put it down here for this one. Right. So I believe, oh shoot, I went a bit too far on that one. Right. Let's press F5 quickly. Still, okay, so now we'll have fixed all these transform functions. We'll update the transform. So shape underscore should be now shape transform dot. Then we'll have, then command underscore will be command transform dot. Fantastic. Rotation angle. Very nice. Right, this one should be taken in a matrix. Yeah, it's pretty handy. Are you doing backing yourself? Not so rare. Planning create my own because educational project, but I'm doing this to learn. Nice. Yeah, like if it's compatible with C, just do a C backend, and then just do a little yeah, x86 one. Should be fun. Like x86, well, I've done it before. I've written a binary before. It is definitely like it's definitely legacy. You know what I mean? Like it's like nothing makes sense. You'll have like a move instruction, and then it will just change. Like the encoding will just change randomly when you do one thing different. But yeah, it's definitely like, you know, it's definitely doable. And you can just do one that goes straight to it rather than having like doing more like an optimizing compiler does, where it has like different layers of high level assemblies just to get it down. Yeah. But it's cool. Matrix multiply, right. So this could be reusable. Did I just say reusable? That's an evil word. When someone says reusable, oftentimes they're shooting themselves in the butt. But yeah, don't worry. So this will be able to be used in shader code and CPU code. Bananas, right? Bananas. Okay, so because of that, this can't be a pointer, but it's fine because it'll get inlined anyway. Because you don't get pointers on that GPE. And voila. So that'll be reusable, CPU and GPU. Pretty good. So then yeah, LEA as well. You got LEA. It's funny how what was LEA? It's called something effective address, isn't it? And but it's for like a multiple. They do it for like ads or something. I forgot what it was now. Load effective address. Yeah, but they do it. Oh, they do it for multiply ad. Okay. The stuff that's a small size type, isn't it? Yeah. So if it's like times by 2, 4, or 8, isn't it? It works. Isn't that right? I forgot what it is. I'm going to switch a light on. I remember looking at the encoding a while back. But yeah, it's pretty cool. It's like a multiplier add. Yeah, nice. What's going on here? I have to deref it. Probably. Oh well. Compiler, optimize it for me, please. Please. Cool. Anyway, so hit compile on that one. This one is saying, oh, right. So implicit start. Okay, so you call this at the start of every clip function just in case, like, so it can start a new clip volume, if you want to call it that. Because you might have said finished on one of them, and then you say, oh, I want to put a shape down, so it's got to start a new one. So this is when it sets it up. So what we need to do here is, so we need to pass in the inverse matrix. So it's like the shape. This guy. It's basically this code. So clip words, please. But then, so you get yourself the proper matrix. The inverse matrix. Yes, this is the inverse matrix. The proper matrix will go into the global under command matrix, which means we don't need the inverse one, I think. Because that's uploaded to the shader. And this will be command transform. Voila. And that's all this code here basically, where it did all the matrix multiply and then reset it back to identity. Easy peasy. So we'll take this with us because we're going to have to do that when we do a draw implicit start as well, which is here. So we'll take all this, put that there. Clip, or it gets replaced with draw. Easy peasy. So one thing I've just remembered is all of this stuff here has to be done right. So you shouldn't be allowed to call command rotate translate shouldn't exist anymore. Wait. Yeah, translation, so shape translate should maybe not exist. Laurie Master, welcome. The x86 had fixed address modes where you basically can only purpose the address using specific combinations like base pointer. So I can't. LEA does those operations and stores a result rather than dereferencing. Yep. It saves some ops because the CPU had to dedicate hardware to the ops rather than issuing multiple ads moves. Pretty cool. Swank Funk, how you doing? How's it going? Did an upgrade. Oh, did you upgrade the quality of your stream here? It looks really good. Thank you. What is an upgrade that you see? I've basically done nothing, I think. Oh, and I did the green screen. That's better. Hey there, Ransel. How you doing? How's things going? Are you prepared for the weekend, Ransel? You all relaxed, you know, doing your stretches? Yeah, it's always been 1080p. I think I had to reduce down to 30 FPS. And I think a while back I did do 720p, and the reason is because when I started streaming years ago, I've been streaming for years now, right? That I forgot how long I've been streaming. Maybe it's been like 5 years. But when I first started, it's 720p, and that's because people were doing all sorts, right? Some people had bad connections, different countries, and maybe going on their phones or whatever. But nowadays, people can do 1080p quite fine. So I forgot when I upped it, to be honest. Um, but yeah. Yeah, and also I think I upped the bit rate. I must have done. Yes, I saw that. Maybe it was within the year I've updated the bit rate. Yeah, I think that is right. Because I saw it was quite low. Because I remember I saw it at like 720p's worth of bitrate, like 2000 odd, but updated to like 4500, which was what they kind of recommend. That's the maximum they take. That's what I do. Eating healthy, stressing over the baby. Thank you, sir. Yeah, no, it's doing good mostly. We're doing good. Yeah. Try to eat healthy. I did go on a bit of a chocolate binge while I was off with the baby, because I was just chilling and relaxing. But I've come off that again now. It was it's building up. Thank you, I'm kept pain. I was celebrating the birth of my firstborn, so yeah, you cannot blame me for eating eating all that chocolate. It was good, and it was bloody hot. So it was like get a nice cold drink, get some chocolate. What could go wrong? Good times. You want to put some assertions. So where we say this sort of like translate. Right. So the shape ones can go at any time, because you can basically say but this one, yeah. So if we go to the actual where the API is being used, right? So the way the API works, right? You just basically say shape, shape, shape. You cannot like do a union on them, right? But you can do these, and you're basically building up like a stack in the background of distances, and you can pop them off with operations like smooth union and that. And then at the end of it, you sort of put some colors down, and colors only work when there's one distance left on the stack. And then you say finish. But then with this whole new transform API, you're allowed to basically if you put a transform sort of modification before you call the shape thing, it will apply to it applies to the next one, right? So these can happen at any time. But the thing is like a new command that happens after a finish. So if you've already put down a shape and you change the command transform, that's an error, right? Because say if you've put down a shape and then you modify the command transform, it shouldn't work because you've already gone and uploaded that to the GPU. And you've already used that current transform to calculate the bounding box for this thing, for this circle. So you can't change it. So what we need to do is we need to say, there's a couple of things, right? So something like assert that this is equal to that and draw command start and the clip commands, the clip words start index. Yeah, so we'll just say UI command transform can only be applied after must be applied before the first shape. And we'll just repeat that across all of these guys. Because if not, you could do it and just be silent, basically. You wouldn't take into account. Something like that. What shit is going on here? Why doesn't it want to work? Oh, is that an S? Damn it. So it's got to be positive. Because negative means that it is being used, isn't it? Yep. Cool. So that's a good little thing there. Does it all compile? Right, it all compiles, which means we're going to the shader code now, fix up the shader code, and then that should be the transform code all working. Pretty good. Did you find a solution for the inverse matrix thing? No. Oh no, I just figured out we need an... Okay. I'll explain the issue. So the first problem is when we're building up our bounding box. So we put a circle down, but this circle could be stretched, right? It could be transformed in some way. And then we need to draw a bounding box around that. So at first we draw the initial bounding box of it. And then we take each corner and then apply the transform, the matrix that we get from the so we turn the transform, which is like skew, scale, rotate, translate, or whatever. We apply that to the box, or to each edge of the box, and get that to recompute the proper bounding box. And then obviously you put down many shapes down, and then you can make your real bounding box. Like so. So this bounding box, we have it so we can texture the overall shape that you've made, right? It's not really a good shape because it's all disconnected and weird, but you can do whatever you want. It's flexible. It's great. So anyway, now the issue is when we draw it on the GPU, we do two things. So the first thing is the way we draw it is we have a thread per pixel. So you're drawing like this pixel here. So you're drawing this pixel here, and imagine if you have, okay, this is a good one. You're drawing this pixel here. Initially the shape kind of looks like this, right? Before the transform. But what you're getting is just, when you're drawing this, you're iterating over all of the commands. The command is this thing in the box, right? And the command has a bunch of operations. So it says shape circle, shape box. And then it'll also say like color it in, and then you'll get the final distance back. It'll say like union them all together, then color it in. And you can use the distance and the color to then color the pixel. Based on how far away you are from the edge of the nearest object. What's in the box? Another box. Dun 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 dun. Yeah, more boxes. So when you have this pixel, its base shape will just be a circle before the transformation. And you apply the transformation. How do you apply the transformation? Right, you're drawing this pixel. So what we could do is we could take the shape and we could apply a transformation to the shape itself and get it to a, is that right? Yeah, we can combine the world matrix and the shapes matrix, right? So the matrix of this thing and combine the matrix of the shape into one matrix, upload that to the draw command or to the shapes little command, and just apply the transform to the shape, and then that will get you like I don't know, technically the shape would probably be over here, you know, 0, 0 coordinates, and then you apply it and you'll sort of land it here or something like that. And then you can take the difference between them or whatever. I'm not sure what it is. Maybe that's not. Maybe that doesn't work. I forgot. Anyway, I thought about this the other day, and it seemed like it correct. But as I'm explaining it, don't think I can remember what I thought of exactly. But the issue with that method, when if I could explain it right, the issue with it is that when you do the coloring, you still need to um you still need to do it the other way anyway. And I'll explain the way we're going to be doing it, because that's what the other way is. Um, so the other way we do it is, so imagine this whole thing could be like, well, no, okay. So we're drawing this pixel. So instead what we do is we use the inverse matrix and get it back to origin 0, 0. And so these shapes will probably be around origin 0, 0 in their most basic form or whatever, right? So there's a circle, there's a box that's like not orientated at all, and there's another circle here or whatever. And you're translating this back into this space. This is origin 0, 0. And then we're doing it that way instead, basically. So that's why we need the inverse matrix. If that makes any sense. Yeah, because we're transforming a point and not the object. That's the reason. So the problem is if we were to translate the actual object, we would need the regular matrix. But because we're translating the point back to the object in local space, you need the inverse matrix, right? Anyway, that's the reason why we need it. I could have explained that better, but that's all I got. What's in the box? Let's pause the music. I've not seen the film Seven, not gonna lie. Rings bells though, I ain't seen it. Is it a good watch? Basically, instead of transforming the shapes to their final position, the inverse transform is the UV pixel coordinate into the shape's local space. Yeah, that's right. Watch it tonight, seriously. I'll jot it down. I can't watch it tonight because I will go to bed after this stream. So, no. So in the shader, we do maths. I know, right? It's mind-blowing. So we need a way. We've got these guys, these UI read whatevers, right? Right, we like reading whatevers, but what we want to read is a new whatever. We want to read in a matrix, right? Isn't she lovely? So we're reading in a beautiful matrix, and for that, we want to say UI matrix M, and we say m.v, and you'll just be doing a bunch of this. So we take out a word, right? You know, it's actually quite performant, believe it or not, it does work. Well, it's fine. Take out a word, reinterpret the bits into a float 32, then we just assign it in here. And voila. It's good enough. You know, it all gets inline and super optimized anyway by the driver, so it's all good. All good. It's very dark, by the way, fair warning. No worries. I'll give it a go. Right, so this guy is gonna make it make the code a little bit easier to read, I guess, and less lines of code probably. We do this thing a few times. So we're just going to say, hey, I got the draw matrix. BC draw words and draw word. So we pull out from the words, right? The words is just basically an array of 32-bit integers that we can use for just arguments of things. You know, and then we add 6 because there's 6 words we've just read off there. Now the clip shape also has a matrix. So you read where the clip shape is, and then you can read in full-on clip matrix. Clip, 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 clip. Reading all that. Very nice. Now, right. So now we go and interpret. So we transform. See, we don't really need the if statement anymore. I did this because we didn't have assignable command matrix, draw matrix. I did this because we don't have assignable arrays, but we have assignable structures, and now the array is inside of a structure, so it's fine. Yeah. So now what we can do is we can simply, oh, we've got a nice function now. We can simply just do this. We can say transformed coordinate is equal to something like, what do we do? UI matrix, matrix what was it called? Matrix transform. What was it called? Matrix mol. It's in the shared code. Shape matrix mol. That is not a good name. I just realized it's just matrix mol v2. Right. Matrix mol v2, that's what we want. So you take in the command matrix. So it iterates over this twice, right? The first iteration, it does the clip shape. So it's per pixel this is running. It goes over all the commands, right? We're going to optimize this so it goes over a small subset of commands. Where's my music gone? Okay, it's coming back, good. And then we just sort of like read out the commands and its clip shape. We iterate over this twice, once for the clip shape, once for the draw command. The reason why we did it twice is because every bit of code gets inlined, and I want this to be reusable. I want to duplicate the amount of code in the binary, so make it so it doesn't get inlined. And we've got some massive switch statement, which is basically the SDF virtual machine in a way. So it's got like some distance stack where we have a bunch of distances which get pushed and pop on a stack, and you basically operate on those distances, and then you compute a final distance at the end, and there's your distance to the edge of the super shape. And you can color it in, you can do all sorts. Never met anyone who disliked it. Cool. Welcome, Chillaxor. How you doing? How's it going? How you been? So we can do command matrix, then we can say with the transformed coordinate, voila, delete this, more simple. So we rotate, so we bring it back, so we bring the current coordinate back into origin 0, 0 based on the bounding box, like the center of the bounding box. Apply the transformation. Why do we bring it back into local space? And then apply transformation. Should we not? This feels dodgy, right? I'm doing okay, doing a lot of Go every day, hoping to get that job. Sweet, nice. That'd be cool. You're doing some server stuff. How are you? Yeah, doing pretty good, man. Doing pretty good. Just been doing, been working, looking after the baby. Doing this project, which has been pretty cool. Been doing some UI rendering. Got this super flexible renderer, doing some like optimizations and stuff with it. Just throwing tons and tons of weird features into this thing, and it's been cool. I like what we've made so far. Yeah, things are going good. I don't know if you've seen, but we also added like gamepad support and Windows and Linux, not Mac. Windows and Linux gamepad support. We've got stuff's coming together, and it's been like 36 days now, I think, or whatever it is, whatever the stream number is. Thank you. Yeah, the baby's good. Baby's awesome. Baby's super cool. It was a lot of fun. Right, so the bounding box is actually, this is the problem. The bounding box is around the shapes that you've put. So you should just put the shapes down in local space, right? Like around, right. Right, what's this bounding box do again? Interesting. Yeah, I think I can do this way better. Yeah. So I think the problem is I'm dealing with the old code, and I was trying to put matrices in it in such a weird way. But now that I really thought about the problem, I need to sort of like I need to clean this up. Yeah. If you want to check for shapes, you need to apply the inverse shape. Yeah. Yeah, local space each object. Perfect. Yeah. So the problem is, these are actually old. Let's get rid of these before I forget. The first implementation of this is like, could I put it as part of the virtual machine? These scale operations. Turns out it's a bad idea. And it's actually cheaper to just upload a little six float matrix per command, and it was basically no performance cost. It wasn't a big performance cost that we saw. It started to get to one we added. Like when it's just 4, it wasn't bad. 4 you couldn't see it. When we did 6 floats, you started to see it, but it wasn't bad at all. Right, so we got rid of that garbage. So the next thing is, the thing I've got to think about is when we do our texturing, that's the biggest thing, right? So when we do the texturing, we take this okay, so the bounding box, the way that, you know what that means? We can save memory. We no longer need a bounding box bottom left. We only need a half extent, right? We need a half size. Because if we orientate the bounding box, is that right? Yeah, this could be an optimization, which would be really great. Because then we can save 2 floats. But let's just think about this. So we initially sub it back. So imagine if we've transformed so we will need so imagine if when we put we say we put shapes down, we put them in local space. We just put them down, right? So we just go, I've got one over here, Okay, and it just doesn't matter. It just puts them down. Yeah, if low left is always origin, then yes, you need the max. Yeah, that would be a good optimization because then we can save on those floats per draw, and then that gets us back. Well, it won't make up for the matrices fully, but it helps. It actually will help on the average, on the most basic ones if they're basic. It will save. So imagine we put down three shapes, and say if we use some really ridiculous coordinates. Say if origin is here for some reason, 0, 0, and you put them over here. Well, what we could do is we can compute the bounding box regardless. Wait, so what we're trying to do? So in the shader, what we need is the ability to check. So given my pixel, translate that back into command into the local space of the bounding box that you've computed, right? That's all you need. So it needs to be transformed back into the local space of the bounding box you've computed of this, right? So the origin would be here. So that's all you need there. So you would need a matrix that takes you back from you need that command matrix, the inverse command matrix. That's what you need. And yes, so you need it for any time you do coloring with sampling or any gradients, I think. Yes. I know I got this. Yeah, it's what happens when you when you take breaks from programming, you sort of logically think about it in the background and then, you know. But yeah, this is much better. So Super True has me all the time. Yeah, exactly. You can just be having a problem for hours. But what you really need is that break. Right. So we will need. So when we build these shapes, at least, then that would just be the coordinates you put in. So this is what I've got to think about. Is the coordinates you put in for these shapes. They are effectively. They are in. This is where I've got to be careful. Because the issue is what happens if you put in this is do we want to center this box back around the origin? So in terms of the API, I guess this is the way we want to think about it. If you say, shape this, shape that at these specific coordinates, right? We probably just want to center that back. I don't know, do we want to do that? Because I imagine if we have, say if we're doing this drawing application, or this ability to make our own little custom, like an editor basically, which allows us to make our own little custom SDF final baked shapes. I imagine you'll be dragging on a circle on a box and changing it. So maybe it stays in the world. Let's just think about that for a second. Say if it stayed in the world off from here. You would then but it doesn't really make any sense, Right, so imagine when you make a new shape, you get a blank canvas, you chuck it down, and then we'll just take the out. Yeah. No, it has to be. It has to be, because you're just gonna make it. Then after you've done that, you've got like a prefab, right, of this command, and you can just put it down anywhere. Then you can transform that around. Right, that makes sense. So when you're doing this space that you're chucking it down, it ultimately doesn't matter because it's going to get standardized. It's going to get wrapped around in a bounding box, then put back into 0, 0 space. Is that right? Because the problem is you're going to encode that. The problem is when you call this, you're going to encode that into the bounding box, which has then been uploaded to here. So we could keep an array, and then we could basically like retroactively go back over and be like, and take that off. We can, because we know where the position sits in this matrix, we can just target those things and just take them off. So there's that. Or we could make an array of matrices and then poke them in at the right place when you say draw finish. Right, so those are definitely options we can do. Unless we restrict it to being in 0, 1 space. -1 to 1. But then that will be a bit weird. I have a few pointers that could help you, but let you burn a few neurons for a bit. Gonna make a coffee if that I feel like you're doing something bad, or comment on the back. Sweet. Thank you. Appreciate it, Suckhead. So we could keep it, we could make it -1 to +1 space. But that would then mean if we put the circles down in this space, it's not going to feel like pixels anymore, right? So that's probably not a good idea because it's not going to be the actual space we want to work in. So, but when it comes to the drawing API, you probably want to go, right, transform this thing, this whole draw command into this place. Yeah, you know what? I don't think we're going to automatically center it. I think that's up to the editor. When we sort of like do the editor, I think that thing will it will do this whole centering thing. Whereas instead here, I think what we want to do is, yeah, I think we just want to say it's from within the bounds of the, or it's based, yeah, so what you do is you say like, yeah, from the bounds of the command, I think. Right, I think that'll work out. So in terms of the shader then, when we take our pixel that we're drawing, we would need this transform, we would need this sort of like, this should probably be renamed to something like coord in So this be known as like command space, right? And that you'll be applying. These are kind of the inverse matrices actually, aren't they? So should we give them proper names? Oh, that was shadowing there. Get rid of that. And then what we're going to be doing, so this is the command inverse matrix. What we want to be doing is take the current coordinate. Okay. And then we apply the inverse matrix and bring it back into the command space. So we'll be using that when we do texturing or doing the gradients. Very nice. That'll be good. And then when we're doing our shapes, that will be the combined. That will be the combined matrix. Yes. So every shape is going to have a matrix. So remember we've got that function which allows us to get a matrix out. So we're going to pull out a matrix. This is our shape matrix, or the inverse shape matrix. So we just pull it out here. So this could be for clipping or for drawing, it doesn't matter. Just shared code. Then we take the coord shape space and we do shape matrix inverse. Okay. We no longer pull out a center position because that's inside the matrix now as part of the translate step. We pull out the radius word, and then what we can do, so it's in shape space. So because it's in shape space, we no longer have to do this, take away from the center position. So now it's simply coordinate in shape space. So coord in, I should probably call it coord in shape space, not gonna lie. Just gonna change the other name quick. Much better. So coord in shape space. So coord in shape space. Wait, this is the matrix multiplier, isn't it? Wait, why are we doing that? Yeah, this was the matrix multiplier, which is done here now. And then all we need to do is calculate the signed distance. Well, we need the absolute ABS coord, I guess, in shape space. Well, you know, it doesn't really matter. We're just going to do this. So we'll calculate the distance. From the edge of the circle, like so. Cool. So now the bounding box is going to be kind of similar. You get a matrix that comes in, so it's not just a bounding box anymore because we can apply this matrix to it, which is pretty cool. So no longer do we extract a center position out of the words buffer anymore because that's part of the matrix now anyway. Wait, that alone removes the two words, which probably was the performance hit in the first place. So maybe the matrix has now been basically free. That's good. Right, we put out the half size. And because we pulled out the half size, we should So we don't need to subtract anymore to get a difference. That's the matrix multiplier, which can go. We need the absolute. Right. So then distance is equal to, well, this thing called d actually. And then we'll do a distance. Oh man, it's called in shape space. Then distance. Fantastic. Right, so all we've got to do now is correct the texturing and then go back to the CPU side and then sort out the matrix stuff again. So we've got to combine the matrices. So this has got to be a combined matrix between the shape and the shape and the command matrix. So texturing. So now the way I imagine it is that the transformed. See, the sad thing is I won't be able to see how much of an optimization. Well, if I can get back the scene I had before and I remember it, maybe we can see how much this helped. We should be able to see the stats, hopefully. Because we'll be removing this one, basically. So it should be less data, I think. Or it'd be less stuff in the registers. So, and this will be faster as well, hopefully, less maths going on. Not that it probably matters with the sample here, but I don't know. Right. Yeah, it probably won't make a difference because it's going to probably end up waiting on a sample anyway. But I don't know. So we're going to have a coordinate in AABB space anyway, or in the command. So the thing is this is texturing the whole thing here. So if you've got this coordinate here, and it's got a valid distance, well, it's inside something, right? Well, it'll try and color it anyway. You got this coordinate here in the local space of this. So, you know, it's in local space. So origin is here, right? So that was the one we did earlier. So all of this basically, so that's screen space, local space. That's unorm. What do we want? We want the coordinate to be, we probably actually want the origin to be down here. Because then it makes more sense for the, where it's going to get used basically. Because it always wants to be, yeah, origin from the bottom left, I think. Well, it depends. For these two it does, but for the gradient, which we didn't update the coordinate to be honest, it needs to be converted into signed norm anyway. Both for the gradients. Okay, so generally it doesn't matter. I think I'll stick to signed norm because it's kind of, it's great. So what we'll do is we'll take offset UV. So the local space of the object, we need So we only need the full-on dimensions. Is there any half dimensions used anywhere? Which one should we use? We'll have it in local. So basically, here's the optimization as well, as we can probably get rid of command AABB dims as well, just by making our matrix translate it into a signed normal space anyway, right? That's the even further optimization. But then we won't get the aspect ratio here. So we would need an aspect ratio passed up from CPU so you could get that right. That's the issue. But that would be an even further optimization, which would be really good. So you can actually get rid of the bounding box entirely. That'd be pretty amazing. Should we try and write the code to account for that then? So AABB, goodbye. I did not realize we could get rid of this whole thing. Oh, no. You need the bounding box for the draw command. Because we're going to be breaking into tiles for the tile renderer. So we'll keep it in there. But it will not be used when we draw per pixel. Instead it'll be when we do it when we break it into tiles. But for now it's going to stay here. But what's great is we don't need the bounding box to live long, at least. And the clip one can also go. Which then means in here, in this loop, we don't need it. Which then means in here. So we're going to assume our coordinate in whatever space is going to be a insigned we can bring it to -1 to 1, and we might not need the aspect ratio actually, because we could have it. We could treat this as +1, and +1 could be all the way up here, and it could be a squared space. Maybe. So maybe it would work. Maybe. For the gradient down below. But let's just write this all out. Let's just get this all in there. No. It would have to be... No, for the texturing, you'd need to have it be this B1 up here. And be nice and snug up against here. So we'll just pass in an aspect ratio for the gradient, I think. That'd be a good idea. Okay. So UV, how do we get the UV then? So that will literally be... So it'll be coord in command space. Now this one, we'll put a little comment to say this is sign norm. Oh my days, what is that doing? In shape space. That should be for that ABB. Right, so we want to turn this into unsigned norm. So it's basically just multiply by 0.5, and then we add 0.5 as well. Okay, so that gets you a UV, then you sample it, bam. So it takes you from -1 to 0 to 1. But we didn't apply this to it. So let's just undo some of this code. Let's get this back. What do we do here? Offset multiplied by this. So this is our offset. Where's the UV bottom left? Did we not use the UV bottom left in this code at all? Oh no, I did. It added it here. Right, let me get all the old code back. Let's put it back in here. So the old code is this. So really this should be offset UV. Offset local space actually. Offset UV times UV size and offset there. Right, so then that would be good. Okay, so at least we don't do a divide anymore. Much better. Cool. S norm to norm, E norm. Right, that's very good. Next one is the color glyph. Sorry, the just glyph basically. It's like a texture, but we just use the sample result differently. It's an alpha instead of an RGB. A, it's just an A. An alpha. Just basically that. No biggie. Gradient linear. So the gradient linear it wants assigned norm. So we do that. Yes, it wants assigned norm. So that's basically that one there. Now the radial gradient, it needs an aspect ratio. So there's no, if we end up giving it the sign norm, I don't want to be using the axis line bounding box dimension. Well, we could do, but then it will keep it long. The problem is it's going to keep it in, it will keep it in like a VGPR. No, it'll keep it in SGPR actually. For two of them. So there's two SGPRs versus just loading, and then it's got to do the division and have the branch. Versus just having it load in and it'll probably be cached anyway. I don't know what is better. But yeah, we just got to remember to do it as well. So this would be the aspect ratio. We got to remember to do that. Then you apply. So the thing is then actually is you need to kind of know which one is bigger anyway, and apply the aspect ratio to it. So you will probably have to pass up 2 more floats. So, you know what? So for this one, you need the branch anyway. You know what? Something like that. Mol. Something like that will do. Okay. So gotta remember to do that. We'll make it not compile at that place. So that's gradient, like radial. So we'll do like to do aspect ratio, something like that. So we need that based on the bounding box. We can do that. Cool. Nice. Anything else? I don't think there is. So we'll look for AABB. Great. So then used up here, which means they've got short lifetime, which means they won't stay in any registers. That's cool. Right. So that's really cool that we can reduce that as less stuff at least. Okay. So where to next? So this is the shader done. Now we have to go back to CPU side, I think. And we've got to sort out those matrices, okay? So I guess let's sort out this one first, we might as well. So we push on the aspect ratio. So it's just a f32 times 2 aspect ratio, and by default it's just going to be 1. Then we do this sort of like if statement where we take the GUI dot draw command. Oh, it's this clip, is it? Right, this is the clip one. So the problem is you need to take the bounding box and actually generate the dims from it. Don't worry, I got that one. Generate the dims, please. Right, so that would be aspect ratio dot y equal this. It could be times equals, doesn't matter, but yeah, equal. Then that's the aspect ratio, that's a times 2, and voila. Perfect. So I need to repeat this code. So the cool thing about this is we have the ability to make your own clipping shape, have little sub shapes, but also draw shapes. And the cool thing is the color mechanism works for the clipping, but it only works on the alpha channel. So you can do all these color operations, sample from textures and borders and gradients, but that's just that's the alpha channel. Like the red channel goes into the alpha channel, basically. So it's super flexible and really neat. But yeah, but obviously there's just duplicate code, which isn't really an issue because it's just duplicated twice. I just have to remember that. So we drop that in there, and then we just repeat this. Right, so now all we got to do is sort out the matrices again. So there's two things that have changed. Firstly, we need a matrix multiply to combine two matrices together. Right, so now the thing is I don't know if this matrix is correct. It's a 2x3 matrix, but I think I did my own format at the end. So let me just rework something out for a second. Wait, okay, I already know this. It's a 2x3 matrix. And what they mean by that is 2 rows, 3 columns. I think. Transform. Let's make sure this is right. You only need it for a 2D. There we go. And they keep, yeah. Yep. And there's a 1. Yes, the bottom row is basically forgotten about. So you can only really multiply. Yeah, you can only really multiply matrices of opposite. Yeah, so it's 2x3, which means 2 rows, 3 columns. So I've kind of probably done the thing a little bit wrong. So I think. So let's just redo this one, right? You've got your sort of like. Wait, what's on the left and on the right again? I forgot, but we'll write it out. So you have your vector, and my music stopped now. So you have your vector, which we'll just imagine would just be like 0, 0, or whatever it is, right? Then you have your, this is 0, 1. Then you have your matrix, which would just be like 0, 1, 2, 3, 4, 5. So basically you get a Well, it's the wrong way around, isn't it? Because this is expecting 3 components out. So the order is this way. Oh, this is such a good thing. I can't believe I got taught this by someone. It's amazing. So your translation is here, I think. Yes, if you do it that way, it depends on the column major and row majorness. This is all very crazy. Yeah, so it's this. Is that right? Or it means that this needs to be... No. Sorry, I just got confused for a second. Don't mind me. Don't mind me. Right. That's it. So, and it produces you this vector. So you do 0 times 0 plus... See, technically there should be a third one there. But there isn't, so it's like basically you just put it... It's that times 1. It'd be 1 on the end. There's like there's an implicit 1 on the end. Right, that's it. So it just ends up being a plus. Okay, so that times that plus that times that. So in terms of, this is obviously matrix, this is matrix 0, right? This one is there, yep, plus this one, right? Times this one, yep, plus 2. So that should really just be 2. Then yeah, so it's 2 then 3. Like we've already done, just follow this thing again. So it's that times that plus that times that plus that times, sorry, yeah, that times that plus that times that plus this times the implicit 1, which will be underneath this 1 here, right? And that gets your y. Right, so let's do the same thing for this matrix here. So it's matrix mole matrix. Now this is technically not possible because it's 2 by 3 times another 2 by 3. Technically what you need to do is you can only multiply a 2 by 3 by 3 by 2. Well, it has to be inverted the other way around. But what we're going to be doing is we're going to be implicitly upgrading them to a 3 by 3. Is that right? And then dropping and have implicit, but dropping the implicit, like we did for this one, right? It's got an implicit component on it, right? So we're going to be doing it for a 3 by 3. Is that right? Right. I got to get this right. So it's let's get some Stoner Rebel on. Cool. So matrix multiplication. Let's go. So you get another vector. It's in line, so hopefully the compiler does what it should do. I'm not really using this in shader code though, so maybe I should just drag it out, to be honest. I don't know. Yeah, let's drag it out. It's really not good to do that. Right, so you'll say... There's an out matrix. Why can't I understand make files? Don't worry, man. Hey there, Richard. I'll let you in on a little secret. You ready? I never understood make files either. They're basically, yeah. There's probably some documentation, very accessible via a man page or something, but you know, I think I Googled for it tons when I first started programming, and basically I couldn't find anything which was easily digestible for my sort of Gen Z kind of millennial brain, so I basically never used them. What I would strongly suggest is doing single compilation unit model, single compilation unit, and having a little script which basically just invokes the client compiler and outputs a binary. All done. So your main file, all single compilation unit means is your main file just includes all your other C files in it. And compile it in. Done. And if you need to have any stuff pre-compiled into some .o files, you can make a little thing. You can make your own little custom build system, which is gonna be way better than make files, way better than any build system out there, because it's your build system for your project, and it's that simple. Yeah, I need to explain YouTube Shorts. Yeah, that's it. Yeah, it's the way you go. Use C for everything. Yeah, you could just and the beauty is your C build script can on Unix be marked as executable and stick a little build thing at the top to compile and run it. What else? Yeah, there's tons of little tricks you can do, or it can just be a very simple shell script away. Yeah, or a little SH file that just infects that, makes that, compiles the build script, then runs it. Easy. I don't mind Unity files, but separating compilation really helps boost compile times depending on the size of the project. Exactly, yeah. But for the most part, people who are asking the question, and especially me right now, you don't need it at the start, but as soon as, you might want a file that gets O2 optimizations all the time, even debug builds. And by having your own build system, you can have that control, and then you can have that compiled and don't have to rebuild it. Yeah. I do get what you're saying though. When we need it, we are definitely going to be doing our own little build system for sure. And then people be like, why don't you just use... have you guys been getting that bun crap in your... okay, there's two crap things going on right now. Tons of Unity talk online, and bun. Like, it was bun before. Like, I was reading through my Twitter feed, and there's this bun package manager program, whatever, just like showing up all the time. It's like, I don't even program in TypeScript. Like, what's going on? And then there's like tons. Yeah, what the fuck is this bun? Yeah, exactly. And then like all this Unity stuff going on as well, just like pure bananas. Like I literally like, yeah, would rather not see any of this and see some like proper stuff, but anyway. As I understand, Ninja for a project I worked on a few months ago. Sweet. How was it? The backwards track and regex takes. Really? They said it was better than Node. That's why you can't trust people who made the thing to give you stats, right? Right, let's bring my matrix multiply scribbles. Right, here's my caveman drawings. So Alright, down these matrix multipliers. You make me do work. So you've got an implicit 3 by 3 matrix. Is that right? It doesn't feel right the way I'm looking at this, because what you're going to produce is then wrong. Have a think. I hate build systems, I hate my life, but it's cool. Nice. Yeah, see, the thing is though, Ninja doesn't do the complicated thing, right, of getting dependencies. You know what does the complicated thing of getting dependencies? Clang, or MSVC, or whatever. You use the -md command or whatever in Clang, and it pumps out a bunch of dependencies. You can parse it, done. Like, you can get all your dependencies for a file. You can then literally just go over all those dependencies and get a timestamp, store that in a file somewhere, and whenever you want to see if a file needs to be rebuilt, you basically get your timestamps for all the dependencies. That's it. Easy. Easy. Build system done. It's not like the tools are already there to build your own build system, and it's like literally a beginner could do it. But no one really describes it because no one really thinks that simple as well. People want to be like, oh, you just use CMake or just use Messen. But really, like, they're more complicated than making your own build system, really. Fun is JavaScript runtime, package manager, test runner. Right. Honestly, it just, like, I don't go in the JavaScript world at all, and I just see it all over my timeline, and literally. So matrix multiplication. So what we want to do is we've got two matrices that we want to combine. We've got the command this thing. We've got the matrix for the shape, which is an offset from here basically, and how's it transformed? Is it, whatever. And we've got the transform, which gets us this command thing. So we want to combine them, right? So use matrix multiply. So let's figure this bugger out. So the problem is if I multiply these two matrices together, well, you can't. That's the thing. You should have a 2 by 3 should be multiplied with a 3 by 2. Sorry. 2 rows, 3 columns should be multiplied by 1 with 3 rows, 2 columns. Yes. So I was saying, well, just implicitly upgrade them to a 3 by 3, and then that solves your problem, right? Because then that's not. So really, this should be like. But then the issue with that is the data's still going to be in the wrong place. Is that right? Let's have a think. Let's just write out and have a think. 6, 7, 8. Oh, matrices. So, to get this number here is that one times that one plus that one times that one plus that one times that one. But then you get this one. And then this one's the same, right? It's the dot product of all of this, of these two vectors, right? The dot product of these two vectors gets you that one. Yeah, then you end up with a 3 by 3. But the issue is I don't want a 3 by 3. I want a 2 by 3 still. And I want it to be all the data to be in the right place. So the issue is these two rows. So this one's implicitly there, this one's implicitly there. Which means the bottom one Yes, I think this works out fine. So we'll call this one like 0, 0. Let's get in there. This one will be 0, 1. There you bugger. This one will be... And then you're just doing something like this, right? So you're going to compute this matrix. And then, so this one is made from dotting this vector with that vector, right? This vertical vector here. So ultimately, right, again, this should be dumb information, right? This is, yeah. Right. Okay, we got this, we got this, we got this. So we should be able to get rid of this row. Yes. We can get rid of this row, I think. Should be fine. So, all we need to do is say out m, or v, 0. Let's go. So this one is the dot of this and this. So it's A. So A is this one, and then B is this one. So it's A, V, 0, multiplied by B, V, 0, plus, and then we copy this, go full ham. All right, so let's just copy and paste a few of them because that's all we need anyway. Right. So then the next one, then it's plus this times that. So that's obviously so this is a 1. This is 3. Plus 2 times 6. No, we don't have a 6. Right, so it's just plus a 2 then. Because that's an implicit 1. Wait, what is 6? Is 6 a 0? Do you just need an identity matrix? So it might not be plus anything. Because an identity matrix would give you 1, 1, 1. Going down the diagonals, wouldn't it? So if you're taking the 6 here as an input, but the 6 doesn't exist, this would be where the translation is, right? 2 and 5 is where the translation is. You don't apply the translation to where the rotation is, do you? Right, so that's another way of thinking about it. So that's a no. So it is, that's then cut off, right? Cool. Yeah, so I'm glad we thought about that. So that's good. So we move on to the next value. So that's this one here. So this one is computed by doing this times that one. So it's that times 1. 1 from A times 4. We have a 4. Then it's 2 times, and 7 is implicit again, but that's not got anything, so we'll leave it alone. Good, goes to the next one. 2. 2 is 0 times 2. 1 times 5. Again, plus this implicit 2 times this one. But this one's a 1, right? Because that's a uniform. Like, identity matrix, this will be a 1, which then means it's plus A, V, 2. And that makes sense, right? Because 2 is where the translation goes, right? So it's just basically adding the 2 in there. So that's really cool. Okay, so now we can take this and we can hopefully just start to, there's a pattern here and we can start reusing it. So we've done this row here now. This row here now, so there's the next row. So all of the B's are going to be the same. but the A's are going to shift down by 1. Basically, right? So all the A's change. So we're doing here 3, 4, 5. 3, 4, 5. So it's really simple, the 2D one. If we did a 3D one, there'd be 2 more of these that we'll have to do. But we just have to change the A ones. So this is now 3 everywhere. So this is 3. Then this one is, the B stays the same. The A on this one though goes to 4, so we add 3 more. Good. And then this last one for A goes to 5. And that's it. So that's the matrix multiply. Hopefully that's right. So delete the workings out, which you don't usually do, but we're going to do it anyway. Now we've got the matrix multiply. Right, so now we'll be able to use that guy. Right. I'm just going to take a quick 2-minute break, get another drink, and then we'll sort the rest of the CPU side code out. I'll be back in a couple of minutes. In the meantime, enjoy the tunes. All right, welcome back, everybody. How we doing? How we all doing? Right. So I've just made this lovely 2x3 matrix by 2x3 matrix multiply. Complete hacks, I tell you. So here she is. So we went and modified that shader code. So we just got to change the CPU side code. Now, there's 2 things, right? Our shape needs to now take in. So when we do that shape matrix push thing, right? What are we doing? So we're going to make ourselves a matrix here. Matrix initialize is going to go ahead and compute us a standard matrix and then an inverse matrix. Okay. Crap went on there. So what we really need to do is, this is our shape transform. Really, these should be better names. These names are terrible names. So we're going to call it command command to shape matrix. These are better names. And this is like shape transform, right? Not good names. Because they're not descriptive, you're just saying it's a... So instead, we're going to say this is a command to shape transform, and this one is a screen to command transform, right? Much better naming. So we can go ahead and make those adjustments like so. So this is command to shape transform. Right. So the beauty is we're going to get ourselves a... Where is it? Right. So when we do a UI shape matrix push, what this is going to be doing is getting... So you need two matrices here. You need the shape to command mate. So that's how you do the inverse, right? I guess, or you can just do it that way. So that one and that one. Something like that. So then this one you need, so this is the inverse, the complete, the matrix we're trying to push here is the complete inverse matrix from screen to the shape. So this is going to be shape to screen. Wait, it's the other way around, isn't it? No, shape to screen matrix, isn't it? Yeah, that's it. Shape to screen matrix. That's the one we want to make. So to make this one, we can then do that new multiply matrix mul, and the out one is going to be this one. And so to get this right, it will be shape this command matrix is going to be screen to command matrix. So that's something else we've got to do a bit of a rename for. Back to 651 where we was. Cool. So we've got that GUI.screen to command matrix. And then we've got this sort of shape to screen matrix. Now, the reason why I've gone and named it like this is so you can know which way to do the arguments. So basically, if you line them up where they match on each, so you know, they should line up like this. So you should say screen and screen next to each other, basically. And that's how you can correctly combine the matrices together in a multiply. So that's a good little naming convention there. And you can do it all without templates, right? Some people do it with templates and they have like a screen template argument. Sorry, space, like a coordinate space template argument, which is like a unit structure, but this just works just as good. So we take the addresses here. Wait, sorry, I did that wrong. Shape to command. So it is the other way around, right? Shape, sorry, command to shape. That's what we want. let's have a think about this. So this one is the standard one. No, we need the inverse matrix. So it is the other way around. Right, we also need the inverse matrix in here as well. We need the command to screen, and we'll make that in a sec. Matrix, that's the inverse matrix. So, gotcha. So it is the other way around. So it's command to screen matrix. Then we say we want the address of shape to command matrix. Perfect. So if you line these guys up, you'll see that command and command are here next to each other, and that's the right way around. And that will get you a shape to screen. So shape to screen, right? You're combining these two which are lined up here, and it cancels them out and just gets you the shape to screen. Voila, magic. So now that's this making sure that the matrix that we give to the GPU is what it should be, is correct, right? So the matrix that we get back out from here is the one that we need to do the bounding box with. But then again, we don't need to do the bounding box. Wait a minute. We need the overall bounding box still, but we only need it for the overall bounding box for the gradient. I think it needs the aspect ratio for the clipping as well. Right, so we'll keep it around. So this needs to be, what does it need to be? Given my local space shape, right? Bring that into screen space for me. So I can make a screen space coordinate. So this matrix here that gets returned needs to be, let's write this in. So it needs to be a screen to shape matrix. And voila. So it's the opposite way around, right? So that's fine. We just do matrix multiply. This time it's just the other way around, right? So it's a shape, screen to shape. This one's local. Then it's these two. Wait a minute. Yeah, these two swap the other way around. And then this one is screen to command. And then this one is command to shape. There you go. And then here we just return screen to shape matrix. So as we saw, right, it's taking, see, command here sort of at the ends, right? And then it cancels those out and gives you a screen to shape, right? And so we want a screen shape matrix. So there we go. Then we reset the transform data. Command to shape transform data there. Fantastic. So now we've got this. This is our screen to shape matrix. So with a screen to shape matrix, that means we can apply it once to this. Yes. And produce the bounding box. Right, so let's go ahead and make those adjustments. Then what else? So So that's just updating all the little drawers we've got there, which is fantastic. Okay, so we've updated the matrices, the shape matrices, and the combined shape matrix and that. But all we haven't done is when we start the command, we haven't actually sorted that matrix out yet. So the implicit clip start, this makes a matrix. So we need the inverse matrix. But again, what is that in a nice descriptive speak? So that one would be a command to screen. See, should it really be called screen though? No, screen to command matrix, isn't it? Wait a minute, did I get it the wrong way around? Right, let's go back. Command, where is it again? Right, let's go back here. Let's just double check this. So the matrix that goes up to the shader needs to be able to take really a pixel coordinate in screen space. Yeah, I named it the wrong way around, didn't I? It's the other way around. You bastard. No biggie. Is that right? So the one that is the inverse. Let's have a think. So what is this one then? So when you're building this transform, you're saying from my command to this shape. No, is that feels right? No, or is this name wrong? Shape. The transform that you're building is to take it from the command, the center of the command to the shape. So the inverse would be shape to the command. Oh, right, here's the problem, is the name screen. The name screen is misleading. So yeah, the name screen is misleading in this thing that we're doing. That's the problem. So really, so let's go back to here. The transform then should be called, so we've got screen. Hmm. Right, so what's confusing about screen? So in the shader, we want to take a point on the screen, right, and bring that into the shape local space. Whereas, yeah, so we want to do something like that. So what we give to the shader should be really screen to screen to shape matrix, right? Screen space to shape space. So when you build this, the first one is the standard matrix. This one's the inverse of that it builds. And So when we give it the transform, which is basically scale, rotation, translation, skew, and it makes that into a matrix, what is that then? So, hey, the code. How bad is the noggin hurting? Should I chime in? Nah. I think I'm doing good. I'm doing fine. It's just lots of working out. Like I've got it logically working. The shader's fine. I'm just sort of like patching in the CPU stuff now. But yeah, I was just thinking out all the But yeah, I'm doing good though. Thank you. Appreciate it. But yeah, we got the GPU stuff all sorted out. It's really cleaned up now. So now we just do this sort of like coordinate command space. So we translate our coordinate back into the bounding box of the command. So that's a lot more simple now. Yeah, and then we've also completely reasoned away the bounding box when we process our commands as well, which is pretty interesting. So that should be a few less SGPRs. But yeah, we also taken the full combined matrix in here, so it's getting pretty good. Getting pretty good. I just gotta sort out my naming conventions and make sure they're fine, basically. So this one's fine, right? A screen pixel to the shape space. So when you have this sort of like shape transform, you're making this taking a command to a shape. Thank you, appreciate it. So this is fine, right? Because you're taking a command to a shape, and that's the transform you build up. And then right. Shape to take a screen pixel and go back to. There's something wrong with the naming. That's what's wrong. So this one shouldn't be called screen to command. You bastard. That's the problem. So this is like, not the command. So this is like, or is it? Maybe it's fine. Right, let's have a think. So this one gives you, right, so what's the problem? So I want to be able to go from the screen to the shape in local space. This here is a transform from the command to the shape, and we compute the command to shape matrix and the shape to command matrix. I feel like these names are the wrong way around, that's why. these names are the wrong way around. But why? No, they're not. They're not. Come on. So this is the command to shape transform. So you're going from the center of this guy to here, translating it from how do you transform to this to here? Damn it. So that's your standard one, and this is your inverse one. Now we need the one that we need in the shader is to take a screen pixel all the way back to the local space of the shape. So I have this screen pixel, and then we translate it back into the local space of the shape relative from the shape, right? So, you know, the screen might be from here, and you're translating it back to here or something. But anyway, relative from here, whatever. So for that, we definitely want the screen to shape. So why is this? Oh. Right, so if this is that to that, let's just think of it as vectors. If this is that to that, and this is that, and what we want is screen to shape. No, this is not good. This is not good. Not a good way of thinking about it. Like this is, yeah, this is a vector. Yeah, it is okay. This is a vector relative from there. And let's say this is a vector relative from there. So if you put them onto the same sort of axis, you get that, right? The same origin, rather. That's what I meant. What am I doing? What am I trying to do? Yeah, so maybe I was wrong where you don't need the inverse. The inverse. Screen to. Yeah, so you got the command to the shape, and we want the shape or the screen to the shape. Screen to shape. That might be right then. You might just need, you don't need the inverse one then. So we don't need the inverse. The drawing software, just search for Milton into Google and you can download it. It works, it's a Windows binary, but you can run it through Wine on Linux and it works fine. Yeah, so we use that one. It's pretty good. So can we think about it in terms of vectors then? Because they don't provide a binary on Linux anymore. They used to, but they stopped doing it. So yeah, he stopped doing it ages ago. Yeah, it's a shame. Not sure why though, because he basically had the code written out for it. But I guess it's just all the different distros. So I guess the portable executable format the .pe, the Windows binary. Turns out it's probably the most portable binary you got. Strange that. Yep, it's one of them. It's like it for Steam now. People are doing that more, which sucks. Because people on Linux couldn't get their stuff together, it's all different. DLLs everywhere, different versions, horrible. So there you go. So what the command to the shape? We want the screen to the shape. We want a screen, what it takes to get the screen to go to where the shape is, bear in mind it's in local space, right? So from this position here or something, I'm confusing myself so hard. Command shape. But we'll follow the name convention right, it leads us right. So I don't ever need the shape to command one you see anymore. Right. My dude, I'm getting tired. I thought there's one problem way too much. My mind. What have I done? Alright, what's another way we can approach this problem? Or what can I do else until my brain's reset? Bum 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 bum. So I think we can shape to command matrix. Command shape matrix. So I think we just need, this takes you from a screen pixel into the local space of the shape. I think that's right. The problem is I confuse myself by thinking I always need the inverse. But maybe that's it. Right, so let's just roll with that then. So that's the shape to screen matrix. Right, that'll make sense based on what we said earlier. Okay, so let's just roll with this one, then it resets the transform back to identity. And then we return shape to screen, right. So we push this matrix on. It's what it takes to get the shape into... Right, so either the naming convention has been the wrong way around. Yeah, there's something fishy with this. And I think we won't find out the answer until we write the implicit start code. Right. So let's swap these around quick to like shape to screen matrix. There's something fishy going on. Shape to screen matrix. Okay. Not that one though. Just all the ones in the shape code. Okay. So when we do this like implicit start, when we do our shape, we go, if you haven't pushed any words onto this command yet, start a new command. And in here, we make a new matrix. So this one, so we want to push on the inverse apparently. And this takes in a screen to command, to the local space of the command. So what it takes to get this screen pixel from world space coordinates, so relative from here, instead to be relative from here, right? That's what the matrix does. So then, so that would just go see, that's not called a screen to command. Transform. I think that's where the problem came from. Is it? It's a command to screen transform. That's what it is. Right, so that's the thing that's been confusing me. Oh my days. I think that's it. So, no? So when you do your transform, where is it? So when you do these guys, when you say, hey, I want to rotate this thing, you're like rotating it around the origin of the command, and then you're translating it into the screen, right? So that matrix, right? So then this one is, so whereas the shape one, you're translating the shape around the origin of the shape. Oh. So this is named the wrong way around. Okay, shape to screen. No, sorry, shape to command. Because that takes the shape and moves it into the space of the command. Okay. And then this one takes the command, moves it into the space of the screen. Gotcha. Right, so that's where the confusion was coming from and causing me to think I needed the inverse, but then when I adopted this naming convention to make it clearer to understand and read what was going on, I ended up using the standard matrix instead of the inverse matrix, and I got confused why, but now we know. So this is end up being shape to command matrix or transform. Oh my days, I cannot believe that just... Can't believe I got stuck on that. Right, then we need to swap screen to command transform to be command to screen transform. Hey Wajilla, how you doing? How's things been? What have you been up to? Shape, matrix, push. Right, so now we can sort this out properly. So we've gone and changed the names now. So this is now the shape to command matrix, meaning that this one is that name and that name is that name. Right, so they swap those around. So this is the inverse of obviously, right, it's command to shape rather than shape to command, right? So turn that transform into a proper matrix. Now this is the screen to shape. This is the one that goes into the shader, which is the inverse, right? So this one is command to shape, which is the inverse one. Bam, good. That's good. So shape to screen, shape to screen, shape to command, and command to screen. Combine those and make that one. Amazing. Beautiful. Doing good. Working on a compiler made in Jai. Awesome. Very cool. What sort of a compiler is it for? Like a little custom language? So the matrix we want to return is what it takes to take a shape and put it into the screen, right? Okay. A shape from local space, put it into the screen. Got it. So that's all good. So now we can go back to that implicit start stuff. Like, this is all fine now. This is the right naming convention. Now we go to the implicit start and we can sort this out. Right. So I don't know what we're doing actually. Right. So this one, we want to be able to take a screen pixel and take it to a command matrix. That's what we want in the shader. So if we take so there's two things we want to do. So this one is going to be, we need both. Okay. So we need to be able to run this and initialize screen which one is it again? Command to screen. Take a command and put it into the screen. So that one will be command to screen matrix. Nice stuff. Is it like systems programming language or a scripting language? Domain specific language? Like what sort of language is it? So this is like, hey, I've got a command and I'm putting it on the screen. So you're making that, and there's the inverse matrix for it. Perfect. So now this one is going to put that inverse one up onto the GPU. GUI.screen2, whatever matrix. Bam. Good. Right, and obviously we use this screen to command matrix when we do that shape matrix push code, don't we? Right. We use it here. So that's super nice. Yeah. Cool. Right, so this is good. We're just missing one thing. See, we've got this shape matrix push. Maybe it might be easier just to combine them. Let's sod it. Let's just make a command matrix push. I didn't want to do it because it's only done twice, but I don't know, it keeps it. So that would be in the implicit starts. And it's basically this code here. Right, so what you're doing is you're putting those in the two locals. Not two locals, two globals. You're calculating, you're uploading that into the words array. And then you're uploading it, then you're resetting your transform back to identity. And that is the command to screen transform. Right, all that can go. Then you probably don't want to return anything. From what I remember, at least, maybe wrong. General, just something I want to use, kind of like C, Rust, C++ mixed. Fair play. Like, is it a good idea to write it in Jai? If it's something you want to use, though, because like Jai is a beta language, and it's up to Jonathan Blow to release it, finish it, and what else? To port it to other platforms is up to Jonathan Blow. So I guess, do you want to put your eggs in those baskets? Is the question. You know, in light of recent news, there's eggs in baskets questions, right? Yeah, if it's just for a learning exercise, by all means, do whatever language you like. You can always port it over, I guess. But yeah. Yeah, also, you want to be careful with bootstrapping too early, because the problem with bootstrapping is if your language has a bug, like a serious bug in it, is it might be difficult to correct the bug when all you have is a compiler made in your own language, right? So yeah, you got to be careful with the bootstrap. So implicit start. So the implicit start now, we should be able to pass in the address to the clip words. And then it just does all the matrix stuff for us. Right, so push in a matrix there. So we also need to use the implicit start for the draw and upload that one as well. Nice. Rightio. Okay. So I'm glad that. Okay, much better. Yeah, so when you unplug and plug, the OBS doesn't pick up when you plug in new devices or something, so unplugged and plugged back in because I nudged the cable. So, the way it goes. Right, so what else did we change? So we need the bounding box because we're going to do a tile-based renderer. The clip box doesn't need to exist anymore. That's the thing I wanted to not forget. So things about the clip box is we only really need it for the gradient thing, so I can do the bounding box. Whatever. But when we do the final upload in finish, we don't need it anymore. So we don't need to upload that, which then means implicit start. We don't need to reserve for a bounding box anymore in the clip shape. But is there a fast clip you could do? You could have a complex box. Sorry, a complex set of clip shapes for some reason. But if you have the bounding box, that could be your quick test to see whether you're inside or not. But then, so that could be a performance optimization, which then means, well, because then you'll be doing less, going over the loops. It might be but how many times would it seriously be hit is the question. Let's grab it back. We can always not put it in and see if it actually helps. Right, let me undo some code for a second. This is the one I wanted. Boom. Programming at light speed. Whoa. Right, we're back. So when we get the clip information, crap, there's more to it. Where did we delete it? Did I delete the whole damn thing? That's not good. Alright, I got that back now. It's mine. Oh. Okay, but still good. Oh, okay. Apologies if that hurt your ears. Alright, so put that back. So I actually want to keep this. So I think that could be maybe a performance optimization if that shape is complex and like the clip. Yeah, but I doubt really if it's going to be a performance because you should. We'll see, right? We'll see. It should probably be CPU side rather than GPU side. I don't know. Let's just try this for a second. We can, when we do our performance optimization stream, we can monkey around with this stuff even more. Coordinate, that's good. In the bounding box of the clip, yep. Right, so something we want to take note of is these matrices now. Pretty cool. These matrices so you need the matrix, that's the question. Of course you do. So this will be known as the clip command. It's the inverse matrix, right? Screen to clip command matrix. This one, yep. Then this one is known as the screen to draw command matrix. And then this one is screen to command matrix. Then that'll be coord in command space. Bam. Would you look at that? So there's the shape matrix, inverse matrix as well. Terrible name, we'll sort that one out. So it's screen to shape matrix. Much better naming, very good. So I think that's basically it now. That's been a lot of refactoring today, but we've done a ton of matrix stuff and everything. So let's just make sure it's all going to compile. Right, we're missing brackets. Oh, this one wants a 2. Yes, we got the aspect ratio on there. Remember we put that in there. Very nice. That was good. Right, so basically, tons of stuff is probably going to be broken. The stream could crash because I've messed around with things to do with shaders and uploading stuff, and so something could probably crash, so just be wary. So let's go. Right, it still runs. We've got beautiful red screen and it's highly optimized now. It's just basically a file clearing the screen. We should only be rendering one thing. So we've got to figure out exactly what's going on. So we've disabled everything except for this rendering here. So let's figure out what's happening at least. You back? We're back. My USB cable got nudged by my chair again. Okay. How many FPS for a red screen? Well, so here's the thing, right? We've got a clear shader. That's our baseline. That's the equivalent of memset for GPU. So that's what is the baseline we're comparing against. Apparently a red screen is getting a 0.6, but I don't know what that even means because it's not really rendering anything that we know we did on purpose, right? So yeah, like this is hundreds of FPS, basically. So let's open it up in the debugger and find L bugger. Core breakpoint. So we're messing with scaling as well. Should we see if that's anything to do with it? So it should just be rendering a bounding box with like a blue color. Horrible blue. Basically, right? So let's put the breakpoint in, jump into the debugger, and find our problemo. So we go into here and do it. So this is our shape API, where we put a shape down, then we say we're going to color it, and then we say we're going to finish it. And then that's a command. You can do multiple shapes and multiple colors and smooth unions, subtractions, all this good stuff. So you implicit start this thing. So you're going to upload right, so make sure we got this right on the shader side. You'll push a matrix. Let's see what we got. Go into here. So our transform is scale 1 1, good. Skew is 0 0, good. Translation is 0 0. Ooh, 0 0. So we should see it around the bottom, at least. So yeah, there's something weird about that. But anyway, let's have a think about this. Yeah, so that's all looking good. It's just reminded me how the sample code might be, I don't know, a bit wrong. But anyway, it makes the matrix just fine. We know this is correct. Yep. Then we invert that. Let's just double check. So that's the invert. Oh, you don't negate the C. You just negate the S. Right, I'm glad we followed that in the debugger, because that's made me think about that. You just negate the S. Right, so just quit out of that for a sec. I don't know if it's, I don't think that's the problem, but we can have a look, right? Right, still got a red screen, no biggie. We'll hop there in the debugger again. Okay, so hop in here. We went in here, we pushed on our matrix. Should we take a look at the final matrix? So we push on 6 words. And it's the GUI.screen. Yeah, that's good. No, it isn't. It's got 100,100. That ain't right. You should be getting 10001, right? Because it's diagonal. Because this is the first row, that's the second row, and that, yeah. So so I changed the format of my matrix, and I didn't update that code. That's the problem. So my matrix was actually wrong. like mathematically, and then I changed it around. So this is, and it used to be 4. This used to be 4, and then this used to be like 2, then 3 or something. But then yeah, I changed it to be proper. Initially, I just put the translation in the I don't know. Yeah, at the end for some reason. Right, so that means this is all wrong. So it needs to redo the matrix multiplication again. Yay. Right, can I quickly think about this being right? So that's your first row, that's your second row. I do have the matrix multiply function right here. It's here. This is this. But they're not in matrix form. So what we did is we took... Right. I've got it. Translation goes at the end. Right? Which means it goes in 2 and 5. What else are we doing about this translation thing? So first row, second row. So that will definitely make it go diagonal now. Maybe this one be diagonal. But I'm wondering if there's any multipliers that needs to be right. So it's shoot. Because this is this one here. That'd be 0. So rotate and scale around the origin, or scale, rotate around the origin, right? And then you translate, right? So I think poking the translate on at the end is fine. But 2 would be, if we multiplied it, be comprised of 0, which is probably this one. Yeah, this one. This one times 0. Wait a minute. Yeah, I think this is going to be wrong. I'm gonna write it out again. I think this is going to be wrong. Right. So basically, what we did is we took a scale x, right? A scale x, a skew x. Wait, I forgot which way around it is now. Down these column majors and row majors. I think it's something like that. And then your translation will be there. So column. Yes, that's correct. So you're imagining you've got like a 2 by with no translation, right? And then you got your imaginary numbers here at the bottom. Perfect. And then you've got um your S, so your rotation angle. So it's C, negative S, S, C. Then no translation. See, but we could bung the translation in there. Yeah, that's the point. I just chucked it on. So it'd be Sx times S times C, right? Let's make these a bit wider. Plus skx times s. So I guess that's negative s then. Cool. And then the next one would be s, right, this times this one plus this one times that one. We didn't get the implicit bottom in as well, but it doesn't matter because these have been 0 the whole time. So then that would be 1 there. So we've got to be aware of that 1. But it's 0 anyway, so that's 0 at the end. Good. So is that right? So you've got your 0, which is scale x times c skew x times negative s. I forgot to put the negative in there. Damn it. Then the 1 column is scale x times s plus, yep. Okay, so we're on the same track here, which is good. We've lined it up. It's the same way. So this one is basically a copy, except that the sx and skx are just y's instead. Right? Okay. Which we see that here. Right, so the answer is we just had the answer actually. What goes in this one? This one, let's put a separator between these. It's a bit more apparent what's going on. So this final one is this one times this one. Yeah. Wait, no, sorry. This one times this one is implicit. Right, it's the scale, isn't it? Shoot. Yeah, this one times that one. Plus this one times that one. Plus this one times that one. Right, so that's implicit. 1. Okay. So, where should my translation go in all of this? So we could just tack it on the end, like we was doing here. Um, Obviously, these have been 0 in the rotation transform. This is the rotation transform. This one is the skew and scale. So, yeah, I think I want to keep the I want to keep the translation for this thing outside of it, I think. Isn't the second matrix supposed to be... Yeah, I've got to change the second matrix. Yes. So this is the inverse matrix. I've got to update this one to be the same, basically. But yeah, good catch though. So that's got to be like this. And I've inversed these around. So then I can rerun it, basically, you know. Should be reversed. SKY. Oh, okay. I did this before, I think, when I buggered it up. Alright, let's read it. SKX. SKX, SK0. You're right. I did that before in the previous stream, didn't I? I remember that. I did that exact thing. Thank you. Yeah, it is that, isn't it? Right, so really... Yeah, because... Yeah, it's right here, because S... Yeah, because there's the skew. Good catch. Yeah. That was right. Yeah. Yeah, so I think basically we just tack it on the end and it should be fine according to the maths. That's my understanding from what we've just discovered there. So before it goes too far, I discovered that transforming the UV coordinate into the object's local space is a lot simpler, like orders of magnitude. So a UV, are you talking about like a normalized UV coordinate? Um, blocks Ray, welcome. I like maths, but I'm not so good at it. Yeah, that's about it for me. I like doing this. Well, I like using maths, but trying to understand it just, yeah, it gets complicated. So I'm not, yeah, not sure. Right, got a good shader toy. Let's open it up. This is the C Daddy example. Right, time to boil my brain. Right, background, normalized pixel coordinates. But it did come out a lot simpler than the other way around. Right, so you're saying transforming from UV to the local space, right? Normalize pixel coordinates from 0 to 1. Transform UV to its center. Yeah. Transform from clip to world space. Oh, here's the shape. Position. You bastard. Right. To transform the world to ray origin to AABB ray origin. Yep. B box, test box. Right, in world coordinates, position times, yeah, okay, so that's going across the X. And then your um so that's the inverse matrix. Yeah. So you got your inverse matrix multiplied by transform from clip to world space. Ray origin, yeah. So the world, okay, the world ray origin. Right, so that's your screen pixel in world space. Yep. So you've gone from, yeah, so you've gone from, wait, what is this? Oh, no, no. Oh. Test shape transforms relative from A to B. So you got your pixel coordinate normalized from 0 to 1. Right, so not so the 0 to 1. Then, see, it's hard to follow code in this because I always want to press the find button and just follow it. I'm used to my Vim. Then you make it from -5 to 0.5, right? I think I'm starting to get it. Then you're timesing it by 50. What's this? Oh, this is the aspect ratio. So to get 100. Right, yeah. Yeah, then your world's ray origin, right? Yeah, I think this is what I'm doing, or what I was doing in the shader, but I've combined it now. So I've combined this matrix and this matrix together. Yes, and I'm just doing a single multiplier on with this when we draw the shape. But when we do the texture mapping, I've got this matrix, and this point that I use to generate this. Yep. Yeah, and I use the yes. If so, for the texture mapping, I've got that one. Yep. So that's what we do. Yeah. So this is the same. That's the same sort of stuff we've got. Yeah, that's good. Yep. That's cool. Yeah. So that's if people are interested. That's basically what we're doing, just in a different way. Right. So I think this fixes the matrix. Basically, that's good. So we run that. We can. So we got. So let's get the breakpoint back open and take a look at the matrix again. So, all right. So follow it through. Implicit start. Get yourself a matrix. So screen to command matrix. Perfect. 1 0 0 0 1 0. Right, because there's 2 rows of 3, and if you line them up, the 1 goes diagonal. Perfect. So that's fine. Then we get the identity back. That's good. So that gets pushed on for the command. Set up the bounding box for some reason. Put on the center position. Run this guy. Just double check it quickly. So this one computes as the matrix for the shape. And we have now computed the command to shape, or the shape to command matrix. Oh, you bastard. Right. So this one, scale and, the scale and rotation is nothing, but the translation's there, which is good. But then if we go the other way around, which is the inverse, we should have done something with the translation. The translation should have been negated. That's probably part of the issue. So we'll sort that one out. And if we're translating by... Right. Yes, it's going the wrong way, I think. So that's why it's probably going off screen. So if you see your shape to... Or your... What did I just print there? The shape to command. So if you see command to shape, that matrix is the same. Oh, that's wrong. Yeah, so it's duplicated the X on the Y and it's not inverted it. Silly me. Right, so we'll sort that one out. So clearly these need to be negated. We'll call it TX, TY. So you'll just take TX equal negative TX. TY. TX, TY, there you go. And beautiful. So, let's see how well this runs now. Fingers crossed that's sorted out because it was going off the screen the other way. Hopefully, that's the way of thinking about it. Right, still not there, but we're a step closer. So let's keep going. You bastard. There we go. Right, so we did that fine. So now let's get this shape to screen matrix. So taking the shape and putting it onto the screen, that is correct. Let's restart that for a sec. I should have checked that inside this function. So you've got your shape. Which one do we want to look at? The command to shape, isn't it? The inverted one. Right, so it's going negative back the other way. That's perfect. Yep, that's the inverse. Is that right? Thinking about it. because it'll rotate it. And translate it back. I don't know if that's correct. I don't know if I'm computing the inverse correctly, because you should be doing the inverse multiply. You should be multiplying the other way around, something like that. Yes, I think that's probably the issue. The only significant difference between what you did and what I did is I believe that you're setting the object matrix based on the world position. But in that order for ABB times local matrix to work. The object based on the world position. ABB matrix times local to work. I'm not sure. Not sure if I get it. But yeah, I'm using big coordinates right now. Because that's just leftover. Yeah, these big coordinates come from the leftover code, basically. But yeah, it is going to be relative. Like this shape is going to be relative from. It's relative from the center of the box. It's like this shape doesn't have world coordinates, even though it seems like it does. It's relative from the center of the box, I think. Something like that. Oh, something might be slightly wrong. It might not be relative from the center. We compute the bounding box. It's relative from the. What are we doing? Yeah, I think I've got to double check that. Yeah, I think I might have to check it. The shader assumes this, what I've just said. But I think we make the bounding box. Oh, the bounding box is used for. It's solely used for optimization. That's why we make the bounding box. That's in screen space. Solely for optimization, so we can bin it into tiles, right? Or whatever, all that crap. So we can bin it into tiles in the future. But yes. It should work like that way, from what I understand. Yep. But I think the problem is my inverse matrix is not inverse. It's pretend. That's what the issue is. Well, basically, we've been doing this mega crazy sign distance field shader thing. We got it all working and everything, but we're adding a final feature which is transforms, and we've just refactored a whole bunch of code, and we're just trying to get it to work again. So I'm just going through the process of finding the issues piece by piece and going from a red screen to a more colorful screen. But yeah. So the current issue is this inverse matrix is wrong. So can I bring back my workings out? I just deleted. Yes, I can. The power of undo. So to go the other way around, right? So what you really want to do, so when you're going from, so this one takes you from imagine you're going to you're rotating, scaling around origin and translating to the place afterwards, right? That sort of thing. But the new one, like, it all depends how the matrix multiply works. But yeah, you want to ideally do the translate. See, I think the translate and rotation can go in the same one, but you've just got it to make it go the other way around. I think that's true. So shall we rewrite it? So let's get this right quickly. SKY, SK. No, I'm not a maths person. I just pretend to be. So I don't know much of the maths tools, not gonna lie. It's probably a good tool. I should probably start using it. So this needs to be rotated the other way around. So that's the old one. That's on the top. We want to do C, C, S, negative C. But yeah, is it a tool you use, Mathematica? Can you recommend it? Then we've got the implicit one at the bottom. We then want an SX, an SKY. An SKX. See, I think the skew X and Y's need to maybe be swapped around. I don't know for sure. I don't know. Yes, specifically for linear algebra, things like this. Fair play. Nice. I just like text files, clearly. And I like pain and misery. Right, it does the inverse. Wait, it gives you the yeah, but the problem is it all in maths notation or is it easy to see? I don't know. Right, so let's rework this out. Here we go. So C times SX, right, C times SX plus S, why is that a negative there? Times SK S times SKY. And then you do 0 times 0, right? But no. Then you do plus 0 times 0, but yeah, no point. Next one is C times SKX plus S times SK or SY. Again, plus 0 doesn't need to do anything. I didn't put my translation in. Please forgive me. Which means you do really have to do it, but then it'll just be plus. No, yeah, then it'll be plus tx times 0. See, I think the translation is just going to get dropped, so I'm not going to lie. There's nothing that's going to keep it. Wait, why isn't it going to keep it? Behold, my awesome paint skills. Woo! Translation would get negated, not zeroed. Yeah, so what am I doing wrong then in the... So was it right? I didn't... Should I have swapped them the other way around? Because that's what you do, right? You're going from one space to another space. No, but I've already inverted them anyway, isn't it? So they would just get negated. Okay, so that's correct then. Right, so there's your little sphere, there's your local space, or inside the box, got your sphere there, got your world. So world UV equals M. I'm not sure exactly for the UV. LUV. Yeah, so to get this one, yeah, a point from translate between the two spaces, relative from the two spaces, right? Is the inverse form of the bounding box. Oh. Yeah. Oh, fair enough. You did plain texting. Yeah, I should probably try and learn the Mathematica. That's fine. Is the inverse of a shape in relative to the bounding box? Right, so what you're saying is... Right, so the fact that I inverse these parameters and do the matrix multiply is good enough. Or make the matrix is good enough. Should be fine. There should be negative coordinates. Yeah, because you're taking the point back. Because I was thinking about the multiply, the way it works, but it should be fine. You inverse the matrix, that's it. Fair. I could write a matrix inverse and figure out, but yeah. Because yeah, this seems wrong at least. Because that would be multiplying it with 0. And there's no way to keep it at the end. You'll be doing 0 at the end. So that's clearly wrong. But why did you gotta translate. Something's wrong with this, right? You do that time. Oh no, you'll keep it. There's a 1. Yes, you do that times that, times that times that, that times that, and obviously adding them all together. So you'll dump it here, you'll dump it there, but you'll keep it there. Perfect. So in that case, it would be yeah, I think this could be right. So the thing is though, wait, what are we doing? So you would invert, why would you invert them the other way around? So because you've got the rotation and the scale. But it seemed like a fine matrix then, didn't it, in terms of the scale though? Oh my days. Do you see what I've just... Oh my days. Can you see what I've just done? Right, let's comment this out for a sec. This son of a... Right, I made these locals, and I didn't go and use them. I think I had it like that initially, but something went up. Something... Ah, you stupid... Yep. Okay. So we'll see whether we need to multiply it the other way around. Let's see if this works now. It gives us what we want on the screen. If it doesn't, we'll try the other way around. Right, thank you compiler for catching that. Very helpful. Right, we hit the breakpoint still. Let's get rid of that. Right, we should be getting a blue screen. See no blue pixel. Is that a blue pixel up there? No, I don't know if that is. Right, so we should be getting an inverse now. Although, I kind of feel like this needs to be... So let's keep both until we've... So let's write the other one, where you multiply these the other way around. So it's like negative s, s, yeah, times sx, c times sky, negative s times c. So the translation just gets tacked on the end because the one there's tx, ty, and that's it. So this would be c times sx plus s times sky. Then it's c times skx plus s times sy. Tx goes in the end. Sx plus c times sky. Then that's right there. Where's the pattern? Wait, shouldn't that be c? Means that's negative s. Yeah, I think mine is fine. Yeah, I think we worked it out okay. We did a 3, yeah, but this is a 3 by 3. Yeah, we did a 3x3, but we stopped at the end. What's the inverse? Oh, this is the inverse code. Ah, I see. Yeah. Nice. Yeah, I think I've got an inverse lane about my code base somewhere. But I might... Yeah, I'll keep that open. We would need that to test it out, wouldn't we? To know which one is which. That's good. Right, thank you. So, SKX... plus C, yep. SK1 negative SKY. Negative SKX. C SY. Right, just double check that quick. So keep the workings out around. CSX, yep, plus, yep. CSX plus, yep. Negative SX plus, yep. C plus, yep, right, it's good. So let's see how that one works. Still red screen. Not too good. So we could get this code, translate it, and then print out the results. And then just see which one is correct. We'll see if either of them are correct, right? So matrix out V. Now the problem is we don't have anything after 5, it's implicit. So what does implicit mean? Well, it's just 0, 0, then 1. Because it's diagonal, we get the 1, right? Is this column major or row major? No, that's cool, I'll just write it out here, no worries. It's column major. I forgot which mine is now. I forgot which one mine is. Is mine column major? That's the question. Where does the translation go in this one? Does it go in 2 and 5? 6 and 7. Damn it. Right. Yeah, it's fine. I can just translate it the other way around. It will still work, but you just have to be aware of it. So just the way you pump it is all. Two, two, two. Yeah, 136. I don't have a 6, so that's implicit 0. 1, 4. That makes sense. 7. I don't have a 7, so that's implicit 0. And this would be 2. 5, implicit 1. Cool. Got a bunch of T's as well. Let's get those T's in there. Got the det determinant. Good old triple equal. And this be your final matrix, right? But obviously we want to so if we get these numbers, so I've punched them in. So what I want to do is get my numbers back. Yeah, I think we'll do something like this. Oh shoot, thank you about that. Cheers. Thank you. To get my numbers back. So we need to remap it back. So we want to say like, you know, expected and we'll do something like float so this be TE yeah, it's an offset, exactly, yeah. Good. So you can jump up basically. To T0 by default, right? I've got to remap it, isn't it? So it goes the other way around. Then it's T3, then T6. Then we want T1, 4, 7. And then we want to say got matrix invert out V0. Cool. Then we'll just throw in abort the bomb. Yay. question mark. So hopefully we'll be able to figure out whether that's the inverse function or not that we're looking for. Damn it. So we run it. Right. So the problem is that we probably want to just apply something. Like we just want to put. So what is this one we're doing it on? Where does it happen first? It happens on a shape ABB, right? Implicit start. Okay. So let's just get some bananas thing going on. Command skew. Okay, let's just do a rotate. Rotate 45. Translate. Scale. Something like that. So we'll put some absolute banana stuff in, and so now we should. Okay, that first one's right. Second one's right. These are okay, except for this last one for some reason. That's the translate column. It's a bit off. So what was that? What one we're looking at for that one? So the translate when we just negated it. Let's have a think. I'll print the original, sure. Thank you very much. Get ready on the screen print, or the print screen. Right, let's give that a run. Right. There's the original. So literally just negated it the other way, which is wrong. As we was kind of thinking, right? It needs to do. It will be in a different space, so it wouldn't be the same translate coordinates but negated, right? So yeah, we're gonna think about that. Thank you so much, Psycode. Appreciate it. So we should be finding out from Psycode if this is correct, basically, because he's going to throw it into his one. And tell us if so. So it's only the translate which appears to be wrong. Why is that? So we should be able to get the translate, it should be the result of this times that plus this times that, which both got 0 in it. Right? Plus that times that, which is 1 anyway, just dumps it in there. So also the numbers are not looking like they're 1 divided by x, are they? They're different. See, we put tx there and ty there. I know, right? It's horrendous. Damn it, maths. If you put tx and ty there, you're just going to get the same thing, right? We've not got anything in these columns here. Is that right? We haven't got anything in these columns here to help multiply with these guys. Sometimes that one. Yeah, we haven't got any. Oh, wait a minute. It shouldn't be putting a 1 in there anyway. Wait, or it should be. Oh, okay. Sorry, I just got confused for a second. Yes, yeah, so it's that one times 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 that one. Yeah, you wouldn't be getting. We need stuff translates in there. Oh. So it's as if the translates need to go into here. Okay. I think I've got it. Now the question is, okay. So the question is, which one does it go on? Does it go on this? And also these are going to be negative. So I think it goes in on the... Right, so this should be tx. No. This is perfectly fine. Except for this tx and ty. So the tx and ty is fine. Sorry, is wrong, but the rest is fine, which means this one is correct. So if we just enable this one for a second, just double checked. What? Oh no, the results are different. Good. They kind of swap the other way around. Perfect. So we do that. The results are fine. Good. So, I was correct by thinking this, which is great. But the issue is that tx and ty are wrong. And the reason is because they need to be put into... They were put into the rotate here, but they need to be put into this one. Tx, ty, something like that. So by doing that... So this means this one only affects this column. So it would be that times that. C, wrong one. C times tx plus S times tx times ty. Then it's yeah, then it's negative S for the other one. Negative S times tx, then C times ty. Right, that should be it. Let's punch that in. Right, they changed, but they're wrong still. You've got some really weird values. Okay. Uh-oh. No. Is it the row major, column major stuff we're mixing up? Are you getting the same values like me? So, So did you do the column major, row major conversion? Yeah, that's the problem then, isn't it? Is mine's in column major, so I had to feed in. No, so mine's in row major or whatever. So I had to feed it in the other way around. Yeah, to feed it in differently into the formula, wasn't it? Something like that. Oh, you transposed. Nice. Right, you transposed it, ran it through it, and then transposed it again, right? Yeah. Good. Sounds good. Nice. Sweet, so what did you get? Nice, thank you. So those are a bit buggered up now. And it's only multipliers. Let's try it again. So this one times this one times this one times that one, which is what we got. Then negative s times. Right, so the sine and cosine might not be what we need to do. But the values seem correct. Let's double check this. So column, row by column. Yeah, that's right, column, yep. Next row, 3, 3, 1, 3. Yep. Then 0, 1, 2, 3, 4, 5, 6, 7, 8. Right, when you've done the reverse. And then we want to transpose it again back. So we're grabbing these are the diagonals. We don't want the last diagonal. We only want this one. That's a diagonal, yeah? Apparently. Well, it's not. So I've done that wrong. This is wrong. Is it? Oh no, these are translations. No. Which one is it? Yeah, I'm not sure what those mean. Alright, let's take a look at this. Right, so you got this. Did I get that -4 anyway? Yeah, I didn't get those in any way. Yep. Thank you. Yeah, I'm not sure then. Let's look in that 3JS code that we saw. So 0, 1, 2, 3, 4. So 3 would be that one, which is R1. That's right. So it'd be 0, 3, 6, 1, 4, 7. Yeah, 1, 4, 7. So that seems fine. Yeah, something is fishy. Yeah, I wonder if it... Why is it multiplying it with another vector? Oh, translate. No, that's not it. I was seeing if I can tell what it is based on. Row, column, row, column, row, column. Yeah, that's definitely different. Yeah, it's definitely column major, so we need to do the flip. The transpose. So that should be fine. I'm plugging my matrix out into there. And that's been transposed correctly. You son of a... Wait a minute. Oh yeah, then I manually inverted these guys. I manually inverted these. And these should only get used... Let's move them underneath here just in case it's messing with stuff. With the manual inversions, then I do these multiplies here. So you know what? Let's just try this. Let's just try and make these 0. And just see what we get. See if we get something on the screen. Because if we get something on the screen, then it means we're pretty close. No, we're not. Right, so it means there's... Yes, so if we got something on the screen, then it meant the translation would just be wrong, but it seems like it could be the matrix and or it could be other code. So, yeah, it's a weird one. Damn it. The maths. Oh. if we put, yeah, but then again, if we ensured 0, we tried that, right? Okay, so should we do this? 0, 0, half the screen in size. That still doesn't work. So that's what we want to get working first. Is can we get something with basically no transform rendering again? We'll start with that, then we'll apply the transform, and then we'll obviously work with that, I think. Right, but anyways, stayed on a bit late tonight, but I got work tomorrow, so I got a jam. Yeah, this was a good stream. I'm glad we've figured out how to simplify a lot of code with these matrices as well. It's just getting them to work is the issue, but we're close. We'll start with the most basic thing and we'll work our way back up again, but that's all good. Right. Oh, so let's find someone to read. Send you guys to Nico. Right. Have a good start to your weekend, everyone. I'll see you all on Sunday. And yeah, thank you for coming so much and for everyone's help and all that. Right. Catch you later, guys. Bye.